Okay. Hi, everybody. Welcome to the talk. The title of this talk is Engineering Better Security. So I wanted to start out by introducing myself. So my name is Karen Sittig. This is my Twitter handle if you want to follow me. I'm a software engineer at Facebook, and I've been working at Facebook for 2 years now. I work on a team at Facebook called the Detection and Security Infrastructure Team, and what my team does is we look for opportunities to build developer tools that will help our developers write code that's more secure by default. So I'll get into what that means in a little bit. I know it's a bit of jargon, but to get a little bit of an idea about why it makes sense for us to have a bunch of engineers that are devoted just to building tools that have security implications, you need to know a little bit more about Facebook, the company. So this is one of the posters that we see on a lot of the walls at Facebook. Facebook has about 17,000 employees, and about half of them are engineers. And new engineers go through a process called boot camp. So boot camp is a process where new engineers go for about 6 weeks. They have some company-wide training. They end up picking their teams at the end of that. But before that, they just get general training. And a lot of that training is on the web product. It's not necessarily job specific. Move fast is one of our mottos. So we actually push code multiple times a day. We're much closer to continuous integration than using versioned releases. And as you can imagine, our security team is not 9,000 engineers. I'm obviously not a product security person, so that's at least one person. And if we were to do traditional security reviews and review all the code in the traditional fashion, there would be a lot of work for each security engineer. So what we do is we try to build in the security into the process of our code development so that we're able to take the load off our security team. This lets our security team do the normal code reviews, do product reviews, but it also gives them more time to do some awesome fun stuff. So I don't know if any of you guys participated in Bountycraft, but Bountycraft was actually modeled after a program that we have in Facebook called Hacktober. And Hacktober is super fun. It's during October, which is National Cybersecurity Awareness Month in the United States. We do a capture the flag, we do a lot of education, we do talks, and this is all organized by our security team. Since they have the time to do stuff like education and outreach, it really helps us have a better relationship with the developers. So when the security team shows up, it's not necessarily because something is broken, it's not necessarily because you've done something wrong, it could just be because they have something cool that they want to teach you. And so again, the way that we get this extra time is by building tools that integrate into the development process. So today I'm going to share some tools that Facebook has built and some tools that other people have built. But the thing that links all these together is they integrate into our web stack. So the reason that I'm talking about the web stack today, we actually have tools for all different parts of the stack. I mostly do back-end stuff with the tooling, but we have lots of tools that integrate into those processes as well. Facebook started out as a website, and so the web development process is the most developed, and a lot of our tools have been open sourced. So everything that I'm going to talk about today is stuff that you guys can actually go home and use as soon as you walk into your rooms. So none of this is Facebook specific, everything you can actually use. So I'm hoping that this talk is going to be highly practical and that you'll all find something that you can actually implement at your own companies or even in your own personal projects. So the format of this talk is I'm going to talk about the software development lifecycle, and I like to think about that at Facebook in 4 distinct phases, and I have a tool for each one. So the first stage is development. This is when you sit down and write your code, and as part of the development process, there are a couple of things you want to think about. After you write your code, you put it up for review. So at Facebook, everybody goes through a code review before they push code out. All code has to be approved by at least one other engineer. But even if you don't necessarily want to do that, I think that there are a lot of benefits to doing code review at your company. And so having somebody validate your code is really awesome. And then after your code is deployed, this is a little bit of tongue-in-cheek testing in production. You never know how your code is going to work in the wild. There are a lot of factors that you can't account for. But I do have some tooling that will help you get around this. And then finally, after your code is deployed, specifically in web development, there's a whole web ecosystem out there. Your website is not isolated. It's not by itself. There are people going to your website from other websites. There are people going from your website to other websites. It interacts with this bigger ecosystem that is really important to keep in mind. And so I added it as a separate step because that's also something that you want to consider when you go into the next development phase and when you iterate on your project, how it's interacting with the other ecosystem. And that's also something that you're definitely going to want to monitor from a security perspective. So the first thing that we're going to talk about is the development process. And the tools here are going to be Hack and HHVM in the XHP library. And so we basically wrote these tools because Facebook was originally written in PHP, and so we wrote this tooling because it's a language that we heavily use. So you've probably seen this picture or something like it. I know it's kind of a joke. There are a lot of things that people don't like about web programming languages, and I think a lot of those objections are valid. I actually looked for one of these pictures using PHP, the good parts, but couldn't find one, maybe because the book doesn't exist. Haha, no, I'm kidding. There's actually an O'Reilly book called PHP, the good parts. There's just no picture on Google Images of that. So Facebook is somewhat famously written in PHP and a lot of JavaScript. And PHP was a pretty cool language when Facebook was first being written, but it's not a very cool language anymore. It's very mature, which is actually pretty awesome. So it's going to be really hard for you to hire a React developer that has 10 years of experience. But PHP has been around for long enough that you can get some people that have done some serious work in that, and that's really cool. There's also a lot of PHP tooling, which I think is really great. And so I would actually say that, PHP might not be sexy, but it's mature at least. And so maybe that's good. And one of my favorite things about PHP is that there's a very low barrier to entry. So actually, as part of bootcamp, every single engineer has to push code to the web. And this means that everybody that gets hired by Facebook has to end up learning at least a little bit of PHP. And to the best of my knowledge, no one has ever, failed in their first couple of weeks because they weren't able to make a commit to www. I actually don't write very much PHP personally. I write a lot of tooling, and so I use a lot of different languages for that. But occasionally I'll have to go fix things in the web repository, and the tooling is definitely very good. And I really like it, and it's super easy. Like just last week, I ended up fixing a bug. I didn't know anything about the code going in. I read it. I read some documentation. I used the languages and the tools that we had available, and I was able to make that commit in a couple hours, even with no prior knowledge. So there are definitely some negatives to vanilla PHP. It's easy to write bad PHP. It's easy to write slow PHP, which is kind of what Facebook ended up learning. And it also lacks some features that are present in more modern languages that end up being really beneficial. So our solution for this at Facebook was we ended up writing a compiled version of PHP called Hack. And so I think the story of Hack is actually pretty interesting. So Hack was a project that came out of my team. We had some people that had compilers knowledge, and they noticed that we were only using a subset of all of the PHP language features. So what actually ended up happening was we noticed that we could just reduce PHP down to that subset that we were using, and we could actually statically compile that. So that's pretty cool. And so that was Hack. Later we have HHVM, which Hack runs on top of. These are two open source projects that are actually both eligible for the Bug Bounty program, if we have any Bug Bounty folks in the audience. But they're also really great languages to work in. One of the best parts of Hack is that since it's compiled, we actually end up getting types. So we're able to do stuff like type checking, which kind of helps us from making some silly mistakes. So I'd like to walk through an example of an awesome Hack feature that I personally really like that's used all over our code base. And so an awesome example of a feature that's present in Hack that's not present in vanilla PHP is asynchronous functions. So first I'm going to show you guys an example of how this would be written in vanilla PHP, and we're going to talk about it a little bit, and then I'm going to show you how it's going to be done in Hack. So what we're going to do here is we're going to write a function that's going to curl two different lengths. So first we're going to curl A, and then we're going to curl B. And the way that we have to do this, because we don't have asynchronous calls, is we have to call them one after another. So you notice here, first we're starting the time, we're curling A, then we're curling B, and then we're stopping. And so the thing to note is that these are actually blocking functions. So even though curl A and curl B are two separate functions that could theoretically be asynchronous, since vanilla PHP doesn't have support for that, you actually have to run them in order. And so it turns out that when I ran this code on my machine, it took about a second. So not super great. Curl A and curl B individually don't take about a second. So I think that we could probably get some benefits from being able to thread. And so one thing to note here is that not only is there an asynchronous curl function that's provided by PHP, it's provided by HHVM for PHP, but JavaScript, which is a pretty cool language, is just now getting await support as part of React. And this is actually something that PHP has had if you use Hack for years. So that's pretty neat. So let's look at what this looks like when we do an asynchronous call. So here we have our curl A function. It looks a little bit different. Our curl B function looks a little bit different. And then what we end up doing here is we end up doing this bulk await. And so something that you should note is this await keyword. This is basically saying like dispatch this call, wait, and then you're going to get a call back. And so another thing to note is that we're actually not getting strings back anymore. We're getting these awaitables. And if you're not prepared for this, this can be really tricky because you might try to look at these like they're strings. And if we forget to do this await here, it gets pretty messy. So one really cool thing about Hack is it will actually warn you if you do this. This is a really common mistake. And so we're able to catch these types of errors before they get pushed out to the server, which is really awesome. So not only do we have this cool new feature that we don't actually have to use Node for, we have type checking, which is great. So we're never going to trip over this as long as we remember to compile first. So this actually has benefits beyond just simple type checking. And the next thing I'm going to show you guys is a feature that we built on that's nearly eliminated cross-site scripting on our platform. So I don't know if you guys went to Jack's talk yesterday, but he mentioned that Facebook isn't super interested in cross-site scripting. It's not because we don't care about it, it's because we've been able to build this tooling to basically entirely prevent it, which is really cool. So, just a quick review. Raise your hand if you know what cross-site scripting is. Yeah, most people do. Okay. Just to make sure we're all on the same page, cross-site scripting is a vulnerability. It's often used to steal user credentials. So that's not great because for us, we care a lot about that. It means that Facebook users can have their accounts stolen. We use cookies to log in. We use cookies for a lot of different things. So cross-site scripting happens because a web page is forced to execute some malicious code that the developer didn't intend for them to execute. And this often happens because inputs aren't sanitized. So it might look like an innocent comment, but it could be calling out to some remote to some malicious JavaScript on a remote server. When you render that comment, it just executes that JavaScript, and you don't know because you're just rendering all those comments. But now your visitors have been compromised, and that's definitely something that we want to avoid. So the way that we got around this was with XHP, and so this little HH here denotes that it's going to be written in XHP. And so XHP is a framework that allows you to write an XML-like representation of your output in native PHP, which is really cool. And at Facebook, we mostly use this for rendering HTML. So if you've heard of React, this is kind of the spiritual predecessor to React. So, it came first. It's pretty cool. And XHP actually comes for free if you're using Hacker HHVM, and it automatically adds a ton of validation. So I think that's actually a great reason to start using Hacker HHVM. Like cross-site scripting, if you're a web developer, is something that you're definitely going to run into. People are going to come to your website and they're going to mess around. And if you're not prepared for it, your users are going to get hurt. And so if you pick a language that has these features in it from the beginning, it's a lot easier because you don't have to do that work on your own. So we're going to look at an example of two functions, one that's going to return the string and one that's going to return XHP. I want you guys to notice that they actually look pretty similar. Like it's not very challenging to write XHP, especially if you're already used to writing HTML. So here we have our vanilla, regular like HTML. So we have the string, it could be bad, and then we're just going to echo it. So we're just going to insert it. So, since you guys are security people, you know that this is a cross-site scripting vulnerability, but I think you're probably not surprised at how often this shows up, and you're probably not surprised at how often people have this in their code bases. Now, note what happens if you use XHP. It looks pretty similar. Basically, the only thing you had to do is add some curly brackets. And then we're going to go and we're going to look at what the output is from calling each of these functions. So here's our example. Our malicious user is doing something awful. I don't know if you guys went on the internet during the 90s, but it was a rough time. The blink tag was very obnoxious. I do not miss those days. So if you're not using XHP, we're going to see that this is just going to blindly render, and now our website is unusable garbage, and we have gone back to the dark ages. So this is something that we would like to avoid. Remember, this doesn't have to be the blink tag. It could be a script. It could be something else. Personally, I think the blink tag is pretty bad, but, insert your own motivating example here. XHP, however, knows that this is supposed to be a string, and so it automatically escapes all of these characters. So notice here, we've automatically escaped all of these blinks. We didn't have to do anything ourselves. It just happened for us. And so that's really cool. We basically just eliminated this cross-site scripting vulnerability just by changing a minor library that we were using. So this actually has a lot of additional benefits that our developers love. So one of the things I've noticed writing tooling is that if you just write stuff that makes developer lives harder, if they're not going to use your things. But if you can give them this additional benefit, like if I go to a developer and say, this library prevents cross-site scripting, you should use it, they might think back to classes that they took in college. They might remember that that's bad. They might know that I'm from the security team, and so they're afraid of me, and so they're tempted to do what I want. But that doesn't necessarily mean they're going to remember. But if I'm able to give them a benefit, and I am able to give them a benefit when they use XHP, then they're going to want to use it because it's going to make their lives easier. So one of the really cool things that we have at Facebook is we've got this big library of components, and that's definitely something that you can also start at your own company. So this makes the look and feel across our site consistent. Developers love it because they don't have to reinvent the wheel every time. So every login box at Facebook pretty much looks the same. And that's not because everybody looked up the definition of a login box and copy-pasted it. It's because we've got this component that everyone can use. And this is also awesome because if we decide to do something crazy like change Facebook from blue to pink, we just need to change that in one place, and that'll get synced everywhere because everyone's using the same components. So our developers love it. As security people, we love it, and we've really gotten a lot of benefits. So I know that this has been a little bit of a pitch for PHP and HHVM, but the next thing I'm going to talk about are code review tools. So now that you've picked a great language, either PHP or something else that has those security features, it's important to get your code reviewed. So raise your hand if you've ever done a code review. Okay, keep your hand up, put your hand back up if you found a vulnerability in code that you've reviewed. Okay, put your hands down. Put your hand up, don't be shy, if you fail to find a vulnerability in code that has been pushed out to production. Yeah, see? So code reviews can't catch anything. I can't catch everything. They can catch some things. And code reviews are great for catching bugs, but personally I think that the best part of code reviews is that they enforce readability. So if you write your code, you can do the best job that you can. You can add tons of comments. It'll be awesome. You can walk through, it's fine. You can add tons of comments. It can be totally awesome. But until somebody else gets their eyes on your code, there's no guarantee that anybody else actually understands what you're writing. And so I think code reviews are really important if you're going to be working on a project, or, if you ever expect anybody else, even just future you, to read your code ever again, because it guarantees that at least one other person knows what you're talking about. And if one other person knows what you're talking about, then probably others will as well. So here's another post that we have at Facebook. It says, nothing at Facebook is somebody else's problem. And we get a lot of benefit out of this. So what this means is that people should feel empowered to go edit other parts of the code base. There are pluses and minuses to this, but one thing that's definitely true is that if you expect other people to go into other parts of the code base that they didn't write, that code has to be readable. Google also has this philosophy. Google does readability reviews, and so large companies understand the benefits of this. And we get a lot of benefits out of having a ton of eyes on our code as well. So not only do we get the traditional security benefits, but sometimes we just notice speed ups. Like we have had week after week people saying, oh, I noticed that there was this issue in this code. Like you used this code pattern that I know is slower than this other code pattern. And so I submitted a diff to update it, and now the code base is faster. And so that's super awesome. And so code reviews are kind of what helps us do this. So code reviews can get really painful. I don't know who hates doing code reviews. I kind of hate doing code reviews. And the reason that I hate doing code reviews sometimes is because the tooling is bad. Like, I don't know if you guys have ever worked anywhere where you copy paste the code like into an email and then or like in a Word doc or something, and then you have to annotate it. But it is a terrible experience. And so we want to pick a tool that makes code review easy. Sorry, I'm actually going to take questions at the end, so if you just don't mind holding on, that'd be great. You can take a picture of the slides so you know what to ask. So at Facebook, we use Fabricator with Arcanist, which is an open source tool. So one of my favorite features of Arc is linting. And so linting basically looks at all of your code and runs some automatic checks to see stuff. So this is actual code that I actually wrote, that I actually tried to put up for a review. And the thing that you should notice is that I've got this extra import, which is not great. So the code is cluttered. Lint rules alerted me to this. I was able to delete this before putting it up for review. So nobody on my team had to tell me, oh, hey, Karen, you forgot to delete this. That's a waste of their time. I don't need my team to tell me to alphabetize my imports. I don't need my team to tell me to add spaces around my equal signs. That's all not important. So lint is a great way to to enforce styling across the entire code base, which allows developers to focus on the actual meat of the code and actually review the content instead of nitpicking about style. And one of the coolest parts about Arc is that there are a lot of open source linters that you can integrate with. So we integrate with PyFlakes, and there are lots of them for various different languages. Hello. Okay. There are a lot of linters out there. They're really easy to integrate. They happen every time you put up a diff because Arc runs every time you put up a diff. So they will happen with every piece of code that your developers write. So it's a really easy way to enforce that styling before stuff goes up for review. Another awesome feature of Fabricator is this thing called Herald rules. This is an example rule that I use. And so what I do is I use this to subscribe to my team's diffs. Now, this is pretty easy. It's a pretty straightforward diff. I have 4 members of my team. If any of us are the author, we're all subscribed. So this helps us keep up to speed. If we add a new team member, we just need to put them on this Herald rule. They're subscribed automatically, which is really cool. So you don't need to worry about that. It makes it easy for you to subscribe to other diffs. Another thing you can do is if you've written any of the code, for instance, and you want to keep updated, see if other people are touching the code that you wrote, so you can learn from them, you can do that. Another example is you can do more sophisticated things. So here's an example of a Herald rule, and this actually shows the interface for creating new Herald rules. So this one is for Jenkins, and it runs tests on push. So this is something that you probably want to do. You've probably got a test suite, and you can do this automatically using Fabricator, which is pretty neat. And so then Fabricator gets this little box. It says whether or not your tests pass. You can do more sophisticated things, like you can reject if stuff isn't passing. Another neat thing about Herald rules is that you can kind of use them as a little bit of a static analysis step. So Herald rules can be used to alert when code re-enters the code base, for example, and this is basically as a last resort. So we frequently use Herald rules when we deprecate code patterns. One example is that we were writing MySQL queries. We used to use MySQL query operator in PHP, but as we got bigger, we implemented our own database APIs to make the calling easier. So now they do stuff like retries, and it just helps everybody to use that library. So you might know that if you Google, how do I make a MySQL query in PHP, you'll probably get the MySQL query operator. But we don't want people to use that. And so we can use Herald rules to add a comment that says, hey, I noticed that you're using this. Why don't you use this other internal library instead? So people don't, again, this takes the load off of the developers who are doing the code review. You can do this with other stuff. So like if there's a pattern that you notice that's causing security issues, you can subscribe member of the security team. Or if you're doing something like if somebody's updating some authentication files or whatnot, you can make sure that a security team member reviews those. So it's a great way to keep tabs on the code base. It's a great way to make sure that stuff isn't getting in. One thing to note is that you actually do need to write your own Herald rules, which is a little inconvenient. They're pretty easy to write, so it's just this, you have your condition and then your action. It's something that comes with Fabricator automatically, which is nice, but it does take a little bit of work from your end. Fabricator has a lot of other nice features. One of my favorite is that you can use reaction GIFs inside your reviews, so that's fun. But yeah, Fabricator is, again, an open source tool. It started at Facebook, and then it actually spun off into a separate company. So open source, you can use it. Arcanist, also open source. You can use it with any language. We use it with Python for one of my projects, not just PHP, but definitely useful. Okay, so the next thing I want to talk about is testing in production. And again, this is a little tongue-in-cheek, but like every time you push out code, you end up doing a little bit of testing in production. It's just impossible to completely replicate the production environment and test. And so one thing that's really hard to account for internally is people trying to hack your site. But fortunately, there's a little bit of a software solution. So raise your hand if you've heard of a fuzzer. Okay, so for those of you that have not heard of fuzzers, fuzzers are basically tools that use random input combinations. They can see if any of them cause crashes. So one of the things you can check are like failed assertions. If you use them in conjunction with a memory monitor, you can detect memory leaks. And at Facebook, we've actually had a ton of bugs submitted by white hats who send us outputs from fuzzers. So they actually really work. And I know that Google has in their bounty program, you can upload a fuzzer and it'll run on the Google infrastructure, and you'll get bounties for any bugs that finds. So these are actually things that really work in the real world. One tool that we've used successfully at Facebook is the American Fuzzy Loop, so AFL. So we've used that at Facebook to detect some bugs, which is pretty cool. And then there are a lot of other open source tools. This is just one that I think is particularly easy to use. So the basic format is, as long as your program can take command line input, you'll be able to use a fuzzer. There are some notes on how to configure it. It's an open source project. You can use it when you get home. One caveat is that fuzzers can be kind of slow. So this is kind of why Google is offering to run your fuzzer on their entire infrastructure. Like, that should kind of tip you off that it's not like a super scalable process necessarily. So you need to run them intelligently. So when you think about places to run fuzzers, great places to run them are places when permissions change. So like if you're going from something to having more permissions, that's great. If you're uploading files, that's another great place to put it. Anywhere you're accepting input is an awesome place. Maybe like your backend infrastructure that's behind like 3 firewalls and Kerberos doesn't necessarily need to have every input fuzzed. But think intelligently. And fuzzers can also be integrated into your deployment process, which is pretty cool. They can just run in the background. You'll get information. One annoying part is that every time you get a crash, it takes a little bit of effort from you, the developer, to actually figure out what caused the crash. So that's something to note, but they can be very, very beneficial. And if you don't have if you have something that's highly sensitive and you don't have the engineering resources to devote to running a white hat program, for instance, you could use a fuzzer to try to find some of these bugs. So raise your hand if you know what this is. No one. Okay. Good, I guess. Like, I don't know, it seems fine. Well, it's a string. And so this is actually a real bug that a fuzzer caught. So this is a string that when you deserialize it, causes PHP to crash, and it was found by AFL. This is present in PHP versions 5.6.6. It was also reproduced in 5.6.5 and 5.6.9. It's on Ubuntu. And it was a real bug that was found by AFL that was submitted to PHP. And so, like, why is this happening? Well, that's kind of a longer story. But the important thing to note is that, like, clearly there's some issue with string deserialization that is going to cause PHP to crash. And it's hard for you to figure out as a developer. It's definitely something that you don't want present in your open source project. But a fuzzer was able to catch this. And, like, would you ever type this in organically? I personally would not. Maybe you're cooler than I am. I don't know. But this is something that a fuzzer can catch that a human might not catch, but that is a real bug present in the system. I see you're taking a picture. It's pretty cool, right? Okay. So again, fuzzers catch a ton of bugs. So I already highlighted PHP. This is on the AFL website. So again, this is one fuzzer highlighting bugs that they think are cool. So this is not everything. And also, like, you could scroll down and there are tons more bugs. So PHP is one. I don't know if any of you guys use Firefox. Not shockingly, there are a ton of in Internet Explorer as well. Web programming is hard. So fuzzers really work. They're really great. AFL finds real bugs, which is really neat. And AFL is super easy to integrate with, which is pretty cool. Okay, so this is actually the cool part of the talk, so everybody wake up now. I see all the heads come up. That was great. So now we're going to talk about monitoring and maintaining your website once it's out. So raise your hand if you're familiar with TLS. Yeah, so TLS is on the internet. It helps keep us all safe. There's a problem with TLS, which is that there are hundreds of certificate authorities that can issue TLS certificates for any website on the internet. So Google actually figured out that there were a bunch of unauthorized TLS certificates that were trusted. There were misused certs that were issued by a compromised certificate authority, made people trust these websites, think they were actually Google. It makes that little HTTPS lock logo show up. If you're in Chrome, it's green. It's not actually green. It's not actually trusted. It's tricking you. It wants your bank account credentials, but you don't know that. So bad certificates also let you perform man-in-the-middle attacks, which are not great for your users. What this means for us is that if a website is masquerading, pretending to be Facebook, basically people will give it all sorts of information. Like, people might tell it things that they're trying to tell their mothers. People might, try to buy stuff, have their credit cards compromised. That's not great. And this is a real issue. Again, like, this happened in 2015. That's not that long ago. And so the solution that we have is the Certificate Transparency Project. So this is built on top of the Google Certificate Transparency database, but we have a real fancy, cool UI that I'm going to show you now. So if you go to the Facebook developers website, which you can do as soon as you get Wi-Fi, my Wi-Fi is real bad on here, you can use the certificate transparency tool, and this is an awesome way to monitor the broader web ecosystem. So one thing that Facebook and Google have going for us that you do not as an individual developer is that we see a ton of web traffic. And we see certificates, people try to authenticate, we see tons of things. We can keep lists, and we can keep track of everyone that's requesting certificates for your domain. So the Certificate Transparency Project is an awesome way to figure out if someone is pretending to be you. And again, this is something that you basically can't do as an individual developer. This is extremely hard to detect, and it requires you to have a lot of data. And so that's why Google started this project. That's why we're helping with it. And I think it's really, really cool. So here's an example of what certificates look like. So I actually subscribe for my website, which is Sittig.com. You can check it out. It does have a TLS certificate. In fact, it has two. So I can go and I subscribe to updates. That's my email address. You don't get to know what it is, but I will receive updates if anybody's attempting to impersonate me. So there are these two certificates. I requested both of them. That's good. And I'll get emailed if anybody else releases them. So I think that there's an obvious sell if you're if you're administering a website yourself. But for white hats, you can actually also monitor domains. So anybody can monitor this. You know, if you guys want to let me know if my website gets compromised, you can also subscribe to updates for Sittig.com. But if you're a white hat, you can see when things change. And so, you know, maybe that's an indication that they've rolled out some new sort of authentication. They've requested new TLS certificates. And so you can also possibly alert companies if they're not aware. Maybe they'll pay out bounties. You don't know. So this is really easy. It's on the Facebook developers site, which is developers.facebook.com. It's under tools. It's the certificate transparency program. And again, it's built on top of the Google Certificate Transparency database. So really cool. Something that you guys definitely should all subscribe to. Okay. So just to recap, we talked about the stages of development, and we talked about a couple tools for each one. So the first thing that we talked about was we talked about actually writing our code, and the tool that we had for that was Hack and HHVM. So again, that was in PHP. That got us a lot of awesome stuff like cross-site scripting prevention. It was really great. It was open source. We've maybe interacted with it for the Facebook Bug Bounty program. But again, super easy to use, a great tool. Kind of one thing to note is that Facebook is pretty committed to PHP at this point. There's like basically zero chance that we're going to rewrite our entire website in another language. And so we're very, very, very invested in HHVM and making it work. And so if there's a cool new feature that you want to use for your website that's going to make it way faster, you can guarantee that Facebook, which also has a website, is probably going to want that feature, and we're probably going to implement it. So again, last pitch for PHP. You basically got all the Facebook developers and the entire development community behind you if you choose to use Hack or HHVM. Next, we talked about code review, and our tool for that was Fabricator. So Fabricator and Arcanist, again, open source, easy to use, come with cool things like lint rules, come with awesome things like Herald rules. Lets us make sure that our code is readable, lets us get other eyes on our code, makes it more readable across our entire code base. Lint rules helped us keep everything consistent so that many of our so that developers could read other parts of our code. And again, that helps get other people looking at it, maybe finding security vulnerabilities, maybe finding opportunities to make things faster and better. After that, we talked about testing in production and maybe using a fuzzer to try to do some of that stuff before we actually push our code out. So we kind of know that the internet is a little bit of the Wild West, and that people are going to try to mess with our website. One of the things that white hats love to do is add a bunch of random inputs to see if your website crashes. Well, a fuzzer can do some of that for you. Again, there is a little bit of overhead. Maybe not the best idea to run it on every single endpoint, but if we have something particularly sensitive that we're changing, it's a great opportunity to use that tool. And then finally, we talked about the certificate transparency program for monitoring our website once it goes live. So we can make sure that nobody's impersonating us, nobody's got fake TLS certificates, nobody's trying to man-in-the-middle our users. This is all great information to know. And so all of these things feed into one end-to-end secure software development lifecycle that we use at Facebook, but that you too can use in your own life. So I think all these tools are really neat. They're all open source. If you want to contribute to them, that's great. If you want to use them, that's also great. We all benefit when the web gets safer. And so I think that if you are starting a new project, or if you're considering adopting some new tools, then these tools are a great place to start. So we have about 10 minutes left. I know that you guys have a break after this, so I'm not going to necessarily make everyone sit here and listen to my very charming and charismatic answers. So if you guys want to go and get some snacks, that sounds good. Otherwise, I'll be here for a couple minutes if anybody wants to talk to me about anything in the presentation. Thanks so much for coming.
So you have 15 minutes. So people have any questions if you're taking questions?
Oh, it's 3:20. Okay. I thought it was 3:30.
Yeah.
First of all, fantastic presentation, and I really enjoyed it.
Thank you.
I want to kind of get your, you see in your code review process, right? You mentioned that there are engineers, you need one other engineer to approve. Is that any engineer or security engineer? I mean, how do you scale your, the thinking is that I'm sure there are few thousand developers and probably hundreds of security engineers. How do you scale?
Okay, so just to make sure that I've gotten your question is, I mentioned in the code review process that you need to have one other engineer review. Who is that engineer and how do you scale that process? Is that correct? Yeah, so typically it's an engineer on your team. So you'll add reviewers, and so I frequently add people on my team. So your question was specifically about the security stuff. So one thing that we don't do is we don't make a security engineer look at every piece of code because that doesn't scale. But the reason that we're able to do that and the reason that we're able to be confident about that is because we've got all this tooling. So I mentioned a lot of tools in PHP. We've also got tools for, again, other parts of the code base. We've got a lot of tools that monitor live traffic and such. So we are very confident in our process. That doesn't mean that no bugs get in, but it means that we don't necessarily have to have a security engineer on every review. We do definitely take a close look at things that we think are sensitive. We do product reviews at a large scale, so we make sure that there's security in every part of the process. But given that we have such awesome tooling, we found that it's not the best use of our security team's time to look at every line of code. But again, we do continuous monitoring. We have a lot of security engineers that are involved in the design process. So security is built in. We just don't need, so since it's built in the whole time, we don't need that last check.
Thank you.
So let me see if I can remember which slide you were on.
I can recall that.
Okay.
Sorry for interrupting during the presentation.
Oh, not a problem.
So, as you just mentioned, the security is inbuilt in your process, like the way in a manufacturing we talk Six Sigma, means quality, whatever you do. There is no need of endpoint review. So do you already built up automated source code review tool? And if so, what is the rate of false positive it throws, which needs to be checked by the code writer as well as security people to judge finally that whether that is it a real threat or whether it can be dealt during production, sent to production or not?
Okay, so the question was, just to make sure I've got this correct, the question was, do we have any automated tooling that does security monitoring? And if so, what is the rate of false positives? Is that correct?
Source code review. I am talking about source code review.
So the tools that we have for source code review, we have some lint rules and some herald rules that alert to code patterns that could be bad. Generally speaking, it's very challenging. We try to make it as hard as possible for people to accidentally write bad code. And so the way that we do that is with the tooling that I mentioned previously. So we do have some tooling that does static analysis. We have a really awesome team that does a lot of that. It's very Facebook specific, so that's why I didn't talk about it, but we do have a team that does that. In terms of false positives, I don't have the exact numbers on that. I'm sure that it comes up. I'm sure that it comes up sometimes. I know that for the most part, like I personally never encountered it. And so one thing, again, to keep in mind is if you're going to do some sort of tooling like that, like false positives are extremely important. And so that's a great question to ask. Like you don't want to get in your developer's way. They're not going to use your tool if it's super noisy. So I don't know the exact numbers. I can tell you that it's low enough that I don't get bothered by it in my daily life. it's low enough that our developers haven't complained enough that we haven't taken the tool down. And so I think that it's probably an acceptable rate.
Follow-up question is, if you maybe number is low, but do you take up process improvement or constantly tweak the automation tool to reduce the false positive? Is there any chance came up in the past that to reduce the false positive you improve the tool itself for the source code review?
So your question is, do we take those into account to tweak the process? Is that correct? Is that your question?
Directly to tweak the process, to reduce the false positive, to suit your environment. Have you changed the tool, automated source code review tool, to make it more, because for eliminating false positive is a cost. It's a huge cost from both sides. It's so to eliminate that cost, do you recommend, or do you start, no, I am pretty fine with it, whatever it throws up?
Yeah, so just to clarify, your question is like, how far do we go in eliminating false positives? Is that, okay, that's close enough. Yeah, so I used to do machine learning, and so I can talk a little bit about this from that perspective. So I think, again, like the risk of, sometimes, especially in security, you want to overpredict, and you want to be careful that you're not overpredicting to a way that's that's going to be detrimental for whatever you're trying to do. The team definitely takes that into account, and that's definitely important. But again, like there might be a certain allowable amount of noise. If we catch all of the things and maybe get 5 false positives, and so like 5 people are a little annoyed because the opt-out process is easy and it's easy to give feedback and the team is responsive and they answer your question, they explain what's happening, then I think that that's a pretty great process. So we definitely take that into account. I agree that it's very challenging to eliminate all false positives, and I would even go a step further and say that in a security context, that's not necessarily something that you even want to aim to do. So thank you very much for your question. I think the guy behind you is
You mentioned that, rules have to be written and stuff like that for the source code review, right?
I'm really sorry. Can you speak loud? Thank you.
Rules have to be written for the source code review. That's what you were mentioning in one of the tools, right? So, just wanted to understand which technology does it review, and do you have inbuilt rules already written so that, people can just pick up from your developer tools and use it?
So sorry, just to clarify, you're asking for the Herald rules. Are there open source rules that you can use?
Yeah.
I do not believe so. It is possible that I did not Google sufficiently well. That being said, they are very easy to write, and I think that you get a lot of bang for your buck. So like if you wanted to spend like 5 or 10 minutes writing Herald rules, I think that you would probably find that beneficial. But unfortunately, I don't know if anything like off the shelf. The particular example that I showed was from Jenkins. So Jenkins might have some specific tooling to integrate, but there are also a lot of examples out there, so it's pretty easy to customize them. One thing I'll note is that like Herald rules are relatively disruptive for engineers. So you don't necessarily want to just download a bunch of rules and blindly insert them into your code base, because then you'll end up getting a ton of alerts, which is really annoying. So I'm subscribed to every single diff by my team. I might not necessarily want to subscribe to every single mention of my name, for instance. And like if your developers are able to pick their own usernames, and some of them pick like cute words that correspond to things in languages, like that's not a rule that you would necessarily want to have. And so I think there is some benefit in allowing people to customize them. One thing that my team lead does is he runs some team-wide rules. So he'll do stuff, for instance, like subscribe new team members, like make sure people are subscribed to updates to our project, that sort of thing. And that's part of like our team housekeeping stuff. But again, like I think that I don't know of an open source library for Herald rules, and I'm not super convinced that you would want to use it anyway. I would encourage you to customize them for your use case. But thank you very much for your question. Cool. Okay. We are right on time. So if anybody has any other things to say to me, I will stand behind this podium until you all leave. But otherwise, thank you very much for coming, and I hope that you have a great conference.